Okay, part 2 on polynomial division is synthetic division. Some of you will find this easier. Here's the main thing about synthetic division. This has to be a power of 1 here. If it was a power of 2, you're forced to do long division. So use synthetic division to find the quotient and the remainder. Synthetic division, a couple of things, remind you. Again, the divisor and the dividend cannot be missing terms. Power of 3, so I have 4 terms. Power of 1, 2 terms, we're good. A little bit different on this one is we take this x minus 2, set it equal to 0, and that gives us x equals 2. This is our divisor. So we put in 2. And then inside our upside down division box, if that's what you want to call it, is just your coefficient. So the coefficient here is 1. This one is -7. This one is 13. And this one is 3. Now, on these ones, some people put a 0 here. Some just bring an arrow down to identify they have to bring the first term down. Anything on the outside of the box, you're going to multiply with the 2. Anything inside, you're just going to simply add down. So this one is outside. 2 times 1 is 2. You bring it up here. And then add down. The -5 is on the outside. Multiply it with 2. You get -10. Add down. We get 3. Multiply that 3 with 2. You get 6. 3 plus 6 is 9. This is our remainder, our constant, our value of x, our value of x squared. These will always go down by 1 power, x cubed to x squared. And our quotient and remainder is now x squared minus 5x plus 3 plus the remainder of 9 over our original divisor of x minus 2. And there you go. That is our answer. We could have done this with long division. Short division a lot of times is a lot quicker and easier. Okay, so let's try a second one. Oh, by the way, we can use the remainder theorem, plug in 2 into all of these, and you'll get 9 as well. Okay, this one here, x plus 3 equals 0, so x is going to be -3, so we're divided by -3. And power of 4 means I should have 5 terms, but I only have 3. So we're going to put 0 for the ones that are missing. So 4, and I don't have anything to the third power, so I have 0x to the third power. I have 0, so we put in 0. No x squared, put in a 0 again. For x, it's -2, and then 5. Bring down the 4. 4 times 3, -12. 0 plus -12 is -12. 12 times 3, 36. Add down, we get 36. 36 times 3 gives us -108. And these added together gives me -110 times 3, -3 gives me 330. And add those together, you get 335. That is my remainder, my constant, my x squared, x cubed. Down by 1 power. So it's 4x cubed minus 12x squared plus 36x minus 110 plus 335 over x plus 3. And again, if you did f of -3, you would get 335. Nothing else, you're checking your math. Okay, don't overthink the synthetic division. It is that simple. We can make it more difficult depending on what is given to do the multiplication. Okay, so this one here, use synthetic division to find the function values, then check your work using substitution. So they wanted you to check your work using the remainder theorem. Okay, so I'm going to put that up there. This is remainder theorem. Okay, I cannot show you the calculator portion, but the I think that's kind of self-explanatory. So f of negative 10, you don't have to change this because this is not in terms of x's. So this would be the same as x equals negative 10. So negative 10 power of 4, if I have 1, 2, 3, 4 terms, I'm missing a term, and it's the cube. So it's going to be 2, 0, 1, negative 10, and 1. Please remember I put in the 0 because I have 0 x cubes. Bring down the 2. 2 times negative 10 is negative 20. Add, I get 200. Oops, I'm multiplying in my head. We get negative 20. Now if I multiply, I get 200. This gives me 201. Multiplied by the negative 10, I get negative 2010. Add down, I get negative 2020. Multiplied by negative 10, I get positive 20,200. Add that, I get 20,201. Now they are asking you to find the function value, and that is the function value, is your remainder. And remainder theorem, you would do the f of negative 10 is 2 times negative 10 to the 4th plus negative 10 squared minus 10 times negative 10 plus 1. And you should get 20,201. So let's try f of 2. Now, if you want, you can pause this and try f of 2 yourself and see how it worked out for you. Otherwise, make the box. We put in 2 here, all those values again. So 2, 0, 1, negative 10, and 1. Bring down the 2. 2 times 2 is 4. 2 times 4 is 8. Plus 1 is 9. 2 times 9 is 18. Minus 10 is 8. Times 2 is 16. Plus 1, 17. And there's the value they were looking for. And the remainder theorem process, f of 2 would be 2 times 2 to the 4th plus 2 squared minus 10 times 2 plus 1. And you should get a value of 17. And then the last one, f of 3. Again, try pausing it, see if you can do it on your own if you haven't already. So my coefficients are 2, 0, 1, negative 10, 1. Bring down the 2. 6 plus 0 is 6. Times 3 is 18. Plus 1 is 19. Times 3 is 57. Minus 10 gives me 47. Times 3 is 141. Plus 1, 142. And then f of 3 gives us 2 times 3 to the 4th plus 3 squared minus 10 times 3 plus 1. And that should give you 142. Calculator you'll have to try yourself, even if you're doing it at school. Okay, so that's the synthetic division. We have one other thing to work on, which is the factor theorem, but it's kind of already been mentioned to you. The factor theorem for any polynomial f of x, if f of c equals 0, then x minus c is a factor of f of x. So this is, I've already pointed it out to you once before. Notice that the c value goes back into an x minus c to get factors. This is a way of getting through something if you're trying to factor, say, something like this, and you're not getting anywhere, is play with values and see if you can get a factor and then bring it down from there. So they want you to use the factor theorem to determine whether the numbers are zeros of the polynomial, and using the factor theorem is that substitution idea. So we're going to do, you can do synthetic or the substitution, either way, because what you're looking for is your remainder 0. So the true question is the remainder 0? If yes, then it's a factor. If no, it is not a factor. So I'll do, since we've got 2 of these, I'll do one as a, using the factor theorem, the other one is synthetic, just to give you guys a little, actually synthetic, you've seen enough of the synthetic. So f of negative 4 gives you 3 times negative 4 cubed plus 11 times 4 squared minus 2 times 4 plus 8, which gives you 3 times negative 64 plus 11 times 16 minus 8 plus 8. So I'm just going to go ahead and cancel those 2 out. And 3 times 64, on my paper I had thrown all of that into the calculator at this point. Hold on, let me grab a calculator. Kind of glad I stopped this because I realized I was supposed to be putting in negative 4 and I was not putting in negative 4. This is negative 4. Oops. Lost the pen too. Negative 4, which makes that positive 8. So let's erase that little bit of mistake. So that should be plus 8 plus 8. So this gives me negative 192 plus 176 plus 16. And that gives me negative 192 plus 192, which equals 0. So since f of negative 4 equals 0, then x minus the negative 4, or x plus 4, is a factor. And what's nice at this point is you can use quick synthetic division on this one using the negative 4, and you can bring this down to a square that can be factored or use the quadratic formula on. All right, so that was f of negative 4. Let's see if I can do this with f of 2 without making a mistake. So this is 3 times 2 cubed plus 11 times 2 squared minus 2 times 2 plus 8. So this is 3 times 8 plus 11 times 4 minus 4 plus 8. So 24 plus 44 plus 4, not going to get me to 0. We already know this is not going to get, this is 0. But 44 plus 24 plus 4 is going to get me to 72. F of 2 equals 72. Therefore, x minus 2 is not a factor. Right. So this is with the factor theorem. And like I said, on this one here, we can use, since we know it's a factor, we can do the synthetic division, get this down to something more doable to work with. The next time we get one that has it, I'll do the synthetic division and show you what I'm referring to there. All right, so I have 2 and -1. So let's try f of 2. So we have 2 to the 4th minus 6 times 2 cubed plus 2 squared plus 24 times 2 minus 20. And that gives us 2 to the 4th is 16 minus 6 times 8 plus 4 plus 48 minus 20. So 16 minus 48 plus 4 plus 48 minus 20. Well, 48 are going to cancel out, and 16 plus 4 is 20, so we have 20 minus 20, which is equal to 0. So f of 2 equals 0. It implies x minus 2 is a factor. Now let me show you what I was referring to, as you can find other zeros using this. So if I quickly do synthetic division, 4, 3, 2, 1, we're good. 1, -6, 1, 24, and -20. Bring down the 1. I'm doing the math ahead of myself. Bring down the 1. 2 times 1 is 2. 2 minus 6 is -4. Times 2 is -8. Plus 1 is -7. Times 2 is -14. Plus 24 is 10. Times 2 is +20. Minus 20 gives me 0. Remainder, constant x. Constant x. X squared, x cubed. So I now have x cubed minus 4x squared minus 7x plus 10. And then we can use factor scales to get this down and find another factor. Or we can simply just play with it. Now, another thing, and this is shown more in the book than it is here, is that now that I know that 2 is a factor, I can use this one, and instead of plugging -1 into this guy, since I already found the factor of 2, I can use this guy to test f of -1, and I'll get the same answer whether I'm here or here. I'll get the same answer. I would like to think I would anyways. I'm starting to second guess myself. I get 1 minus 4 plus 4. I don't want to test it. So f of negative, it will just give you, if it's a 0, it'll give you 0 again. That I do know. So I have -1 to the 4th power minus 6 to the negative times -1 to the 3rd power plus -1 squared plus 24 times -1 minus 20. This is going to give me 1. This is going to be negative. That will be negative. So plus 6 positive plus 1. That's negative. -24 minus 20. 6, 7, 8 minus 44 is going to give me a -36. So that implies f of -1 does not equal 0. Therefore, x plus 1 is not a factor. Now, I may not get the same number, but I will still not get 0 if I plug -1 into this. -1 cubed will still be -1. This is going to be positive, which keeps that to be negative. Those two become positive. So I'm not going to get the negative 36, but I do get a number that is not equal to 0. So this is what I mean. I may not get this value. If you're looking for the actual value of f at -1, you're going to get negative 36. This one I took a factor out, and that gave me the factor of 12, or the value of 12, which is still identifying as not being a factor. Okay, so x equaling -1 is not a factor either. Okay, and then this brings us to the our last examples, and I do have this one in my notes to go over in class. There's a couple of things that we need to do on this one. We can go ahead and test this one. It's this guy we got to talk about. So I'm going to go ahead and talk about this one, or not this one. I'm going to go ahead and do -2, and then in class, we will do the positive negative I. Okay, so f of -2 equals -2 cubed plus 2 times 2 squared plus a -2 plus 2. And I hope you guys can see that already it's going to fall out. We get -8 plus 2 times 4, which is positive 8, minus 2 plus 2. Everything's going to cancel out. We get 0. So f of -2 equals 0. Therefore, x minus the -2 is a factor. Okay, and now that we've got these as being factors, we can use synthetic division to get something smaller out of this. So 1, 2, 1, 2. Gives me -2, which is 0, which is 0, which is 1, which is -2, 0. Remainder constant x squared. So I have x squared plus 1 is my other factor. And now all we have to do is use the I and I squared, so we can use this one to test that one. But I want to show how to do these in class. So we'll finish this one in class. So making myself a note so I don't forget when we go through these. All right, but I can go ahead and assign the homework. There you guys go. I already assigned problems 1 and 3. You should have these already done by now, and 11 through 37. Every other odd is what's going to be left. Okay, good luck on those.